Hello, I am Dr. Shopna Roy. Today we will learn how to draw the phasor diagram of Sauty bridge. As you know, this is the figure of Sauty bridge from where we can measure the unknown capacitance. This is a very simple bridge. Here, this C1 is the unknown capacitance, and this is the general equation for any bridge for balancing equation. This Z1, Z4 product of opposite arm impedances must be equal. Z1, Z4 is equal to Z2, Z3. So for any bridge, first we have to find out the arm impedances. So from that, we know that Z1 is equal to 1 by j omega C1 and Z2 is equal to 1 by j omega C2. Z3 is equal to R3. Z4 is equal to R4. So using these equations we can find out the value of unknown capacitance. Now how to draw the phasor diagram. Here we can see this current is I1, this current is I2. Now when the bridge is balanced, no current will flow through the detector. No current will flow through this detector, so the entire I1 will flow through this path. So I1 is equal to I3 and I4 is equal to I2. So in phasor diagram, first we will draw, this is I1, I2 current phasor. Now this drop, the drop across the capacitor will lead the voltage. Now this is my E1, that is voltage, potential between A and B is E1, and potential between A and D is E2, and this potential is E3, and this potential is E4. When the bridge is balanced, E1 must be equal to E2, that is potential at this point B and D will be same, and potential E3 is equal to, that is this one, is equal to E4. Now what is E1 and E2? So E1 and E2 and both will be same. This is in case of capacitor current lead, so this is I1 by j omega C1. This is equal to E1. The same thing, E2 is equal to I2 by j omega C2. Now I1 R3, this drop, and I4 R4. I1 R3 is equal to E3. This is equal to E4 is equal to I2 R4. So we'll connect it and we'll draw the diagonal. So this is my E. So E must be equal to E1 plus E3. Similarly, E must be equal to E2 plus E4. Now remember that in Sauty bridge the capacitor used must be lossless capacitor. If there are some losses, so that time we have to modify the de Sauty bridge. So how to modify the de Sauty bridge? And this bridge is called modified de Sauty bridge. So I will draw the modified de Sauty bridge. So in place of the capacitor, I will add one resistor R1. After that one capacitor C1, then the loss component, this is denoted as R1. So this R1 is the loss component. It represents the loss component. And in this arm, there will be resistance R2, capacitance C2, and another resistance small to R2. And here it is as usual, this will be my R3, this will be my R4, and this one is the detector D, and supply is connected here. So this E1, the potential between the point A and B, this is E1, and the potential between A and B, this is my E2, and this potential is E3, and this potential is E4. This is the modified de Sauty's bridge. This is modified de Sauty's bridge. Now I will draw the phasor diagram for it. Similarly, this one will be my reference line I1, I2, this is my I1 by omega C1. I1 by omega C1 means this one. This potential is, this is EC1, and this potential is EC2. See, note down this one. The potential between C1 and this small r1 is EC1. So E1 is equal to I1 R1. This E1 is equal to I1 R1 plus EC1. Similarly, this is my I2, this is my I2. So I2 R2 plus EC2 is equal to E2. So this is my I1, this is my I1 R1. This is I1 R1. And this is equal to E1. E1 is equal to I1 by omega C1, and this is my I1 small r1. Now, if you draw this rectangle, you will get, this is your EC1. That means this is your EC1. So EC1 plus I1 R1 EC1 plus I1 R1 is your E1. Now E2 is equal to I2R2 plus EC2. So we have to draw the EC2. So I am considering this portion is my I2 R2, that is dropped due to this. This is my I2 R2 and this is my I2 small r2. So accordingly I will draw this one and I will get the value of EC2. So EC2 plus I2 R2 is equal to E2, and E1 and E2 must be same. So this is my E2. So I2 R2 plus EC2 is equal to E2. So what is E? E is equal to E1 plus E3 as well as E2 plus E4. What is E4? E4 is equal to I2 R4. And what is E3? This is I1 R3. So you have to draw I1 R3. So this is my I1 R3. So this is equal to my E3 and this must be equal to my, this is E4, that means I2 R4. Try to concentrate at this point. What is I1 R3? This is E3. E3 must be equal to E4 is equal to I2 R4. Now E1 plus E3, E1 plus E3 is equal to E. So I have to extend this line and I have to draw this E1 over here. So this representing my E1. E1 Phasor sum of E1 plus E3 is equal to E. So this is my E. Similarly, E2, this is E2, E2 plus E4 is equal to E. So this one is the modified Sauty bridge Phasor diagram. Now the loss angles. The angle delta 1 and delta 2 are the phase angle of the capacitors C1 and C2. So this is called capacitance C1. So this is my delta 1, phase angle of the capacitor 1, and this is delta 2, that is E2 is equal to I2 by omega C2. And this E2 by I2 by omega C2 and I1 by omega C1, it representing the same line. This drop plus I1 R1 drop is equal to EC1. Similarly, that is I2 by omega C2 draw plus I2 R2 is equal to EC2. So EC2 plus I2 R2 is E2. Similarly, EC1 plus I1 R1 is my E1, and E1 plus E3 is equal to E. E2 plus E4 is equal to E. So the phase angle of capacitor 1 is capacitor 1 C1 is equal to delta 1, and phase angle of capacitor 2 C2 is delta 2. So dissipation factor is denoted as D, and this one is equal to for capacitance 1 C1 it will be delta as 10 delta 1. 10 delta 1 means 10 delta 1, that is this I1 R1 by this one I1 by omega C1. So from this I am getting I1 cancel. So omega C1 R1 is the dissipation factor for capacitance 1. Now D2, similarly D2 is equal to 10 delta 2. This is equal to I2 R2 by I2 by omega C2. So this is equal to omega C2 R2. So at balance we can write that at balance we have R1, capital R1 plus small r1 plus 1 by j omega C1 multiplied by R4 is equal to R2 plus small r2 plus 1 by j omega C2 into R3. So what I am getting, R1 plus small r1 into R4, this is the real part. It must be equal to the real part of this right hand side, that is R2 plus small r2 into R3. So R1 plus small r1 by capital R2 plus small r2 is equal to R3 by R4, or just reverse it, R2 plus small r2, so R1 plus small r1 is equal to R4 by R3. Now this is the real part. Imaginary part, what is this? In imaginary part we can see that R4 by omega C1, R4 by j omega C1 is equal to R3 by j omega C2. J omega cancel. So C1 is equal to R4 by R3 into C2. So that's all. This is the dissociative bridge. So practice it. Practice the phasor diagram. Thank you very much for watching. Please press the like button, share and subscribe me. Thank you.